Hey guys, good morning. Long time no see. Man, what a crazy couple weeks we've had, huh? Um, we're going to get back to our project today. I did not post anything and I didn't put anything out to be picked up because this is what we're in the middle of. And I wanted us all to get started back on the same foot at the same time. But we are going to pick up the pace a little bit since we've missed an entire week of instruction. We're going to pick it up a little bit and do 2 parts of our project every day, okay? So we will start off slow. We're going to do the sun and the asteroid belt today, okay? So let's get started talking about the sun. Okay, our sun is a star. We've established that already. The sun is the heart of our solar system. It's a yellow dwarf planet, or a dwarf star, that provides heat and light throughout the solar system. Its gravity holds everything together from the largest planets to the smallest particles of rock, ice, and debris. And without the sun, life on Earth would not be possible. Let's get up here so I can go on forward. Remember, you can stop, pause, and go back as you need to. 5 facts per component. Sun, you need 5. Asteroid belt, you'll need 5 as well. So what is the name of our sun? I've had many students ask me, well, there's Saturn, there's Uranus, there's Pluto, or Neptune, Mars. All of the planets have these names, but then there's the sun. It's just the sun. Unlike other stars such as Alpha Centauri, Sirius, and Rigel, our sun does not have an official scientific name. We usually just call it the sun, but some use the Roman name Sol when in referring to our sun, because after all, this is where the term solar system comes from. The sun accounts for 99.86% of the mass of the solar system. And there's an image in a video that we're going to watch here in just a second that will blow your mind. Okay, when we picture the solar system or imagine the vastness of the solar system is just mind-blowing. But by mass, the composition of the sun is 75% hydrogen and 25% helium, which are gases. And the sun is about, listen to this, 330,000 times more massive than the Earth. Okay. So now, how hot is hot? The temperature of the sun's surface is about 10,340 degrees Fahrenheit. That is unimaginable. Temperatures inside the sun, however, can reach up to 27 million degrees Fahrenheit. The sun is about halfway through its life. Yes, it is a star, which stars can and do burn out. At 4.5 billion years old, the sun has burned off around half of its hydrogen and has enough left to continue burning for about another 5 billion years. Alright, so here's a video I wanted us to watch, and then we'll do our learning check.
While billions of stars are scattered throughout the universe, the one at the center of our solar system plays a special role for us here on Earth. Our sun formed about 4.5 billion years ago in the Milky Way galaxy's Orion Spur. It was born when a cloud of dust and gas, known as a solar nebula, collapsed. And in the middle of this formation, matter condensed into a burning ball of gas that became our sun. The sun's fiery nature, along with a tremendous gravitational pull and an extensive magnetic field, helped it to become the heart of our solar system. The sun can be divided into 6 layers or regions: the corona, the chromosphere, the photosphere, the convective and radiative zones, and the core. In terms of atom count, the sun is about 91% hydrogen, the sun's fuel, 8.9% helium, and 0.1% heavier elements, such as carbon and nitrogen. Due to the sun's extreme temperatures, these elements stay in a gas-like phase called plasma. In the core, temperatures reaching at least 27 million degrees Fahrenheit, combined with the sun's powerful gravity, fuse together hydrogen molecules to create helium. Called thermonuclear fusion, this releases an enormous amount of energy in the form of radiation, electricity, solar wind, and, as we experience on Earth, life-giving heat and light. Such volatility is contained thanks to the sun's tremendous gravity. It's strong enough to hold the solar system intact and is primarily due to the sun's size and mass. Our sun is the largest and most massive object in the solar system. It's more than 100 Earths wide and could theoretically fit all 8 planets inside nearly 600 times. It also contains approximately 99.8% of all the mass in the solar system. Because of this mass, the sun has a great pull on the fabric of space, creating a gravitational force that causes nearby planetary bodies to be drawn toward it. This gravitational pull allows the sun to hold together a system of 8 planets, potentially dozens of dwarf planets, at least 170 moons, and countless comets and asteroids. Without the sun's gravity, these celestial bodies would drift off into deep space. Another critical property of the sun is its magnetic field, which encapsulates the entire solar system. Called the heliosphere, this force field protects the planets from harmful cosmic radiation. It's caused by the sun's plasma pushing electrically charged particles toward the star's poles. This process turns the sun into a giant magnet. Although the sun's magnetic field is invisible to the naked eye, its effects are noticeable. On the sun's surface are dark areas called sunspots, which mark strong pockets of magnetism. On Earth and on some of the other planets, the sun's magnetic field interacts with their atmospheres, resulting in beautiful auroras. Despite its size and strength, the sun will not last forever. In about 6.5 billion years, it will run out of its hydrogen fuel, expand to envelop Mercury, Venus, and even Earth, and then collapse into a small star known as a white dwarf. In the meantime, the sun will continue to play a critical role in the system that bears its name. The sun's protective magnetic field, tremendous gravitational pull, and ability to create vast amounts of energy will protect, contain, and give life to our solar system.
Okay. Alright, so learning check. What is the source of the sun's light and heat energy? The fusion of hydrogen molecules to form helium in the sun's core. Thermonuclear fission, created when atoms in the sun's core split and released energy. Superheated carbon, created by the intense heat and pressure in the sun's 27 million degree Fahrenheit core. Okay, so be thinking of that. Alright, so now we're going to go back to the menu and we're going to look at the asteroid belt. Okay, so like I said before, make sure you pause, get down those 5 facts. In class, we did some really fun activities. We created the solar system using students. We got everybody in order, how they rotated, so that was really fun. I wish you guys could be here to participate in all those things. But as we move on, we're going to talk about the asteroid belt. Okay, the asteroid belt lies between Mars and Jupiter. So as you can see, here is where the asteroid belt would lie. And that is about 205 to 297 million miles. Okay, here we go. The asteroid belt is made up of trillions of space rocks ranging in size from dust size to dwarf planet size, which is 1/4 the size of the moon. Okay, here's another video about the asteroid belt.
It's one of the most fascinating areas of the solar system, and it's also probably the one that's most often portrayed inaccurately in media. The asteroid belt is usually depicted as a perilous obstacle course of flying rocks. Even in the Cosmos reboot, Neil deGrasse Tyson is shown darting around it in his spaceship of the imagination like he's steering the Millennium Falcon through the Hoth asteroid field. But it turns out that if you're in the asteroid belt, it's easier to fly through safely than it is to actually find an asteroid. Located between the orbits of Mars and Jupiter, the belt covers an enormous region, about 2 to 3 times the size of the Earth's distance from the Sun. That's around 50 trillion cubic kilometers. And while most of that is empty space, it does contain trillions of space rocks, ranging in sizes from bits of dust to a quarter the size of our moon. And together, they have perplexed astronomers for centuries. So where did the asteroid belt come from? Astronomers used to think that it held the remnants of a planet that was destroyed by a comet or a collision with some other protoplanet in the earliest days of the solar system's formation. But it turns out that there's not enough mass in the asteroid belt to account for even a small terrestrial planet. So far, we've only found 4 objects in it that are more than 400 kilometers in diameter: the asteroids Vesta, Pallas, and Hygeia, plus the dwarf planet Ceres. Together, those 4 objects contain more than half of the total mass of the asteroid belt, with Ceres accounting for most of that. There are also too many chemical differences among the asteroids for them to have originated from a single object. Most of them are composed of rocky minerals, for example, while a few contain mostly metals like iron and nickel. So, more than likely, the asteroids are remnants of the solar system's formation 4.5 billion years ago. As our system's giant disk of gas and dust slowly accreted into larger and larger particles, eventually forming planets, some swaths of the material weren't able to collect into anything. In the asteroid belt's case, the enormous gravitational pull of Jupiter likely prevented those particles from coalescing into even a small planet. And they're not the only leftovers we've found from those early days. The asteroid belt is sometimes referred to as the main belt to distinguish it from the Kuiper belt. That's the big band of debris out past Neptune where Pluto and other dwarf planets hang out, and it's thought to have similar primordial origins. To learn more about the vestiges of the solar system's birth still floating around in the main belt, NASA has sent the Dawn spacecraft to investigate. In 2011, Dawn orbited Vesta, where it mapped the giant asteroid's entire surface and found that it's more geologically complex than we thought originally, with a crust, mantle, and an iron core, more like a protoplanet than just a chunk of rock. And now, Dawn is en route to Ceres, the largest object between Mars and Jupiter, which has already been found to have water ice on its surface and even a thin atmosphere. It'll take up orbit there in 2015. And by the way, Dawn joins more than a dozen other spacecraft that have navigated safely through the asteroid belt in case you needed any more proof that it wasn't some celestial minefield. Pioneer 10 became the first to make its way through in 1972 with no laser cannons needed. Thank you for watching this episode of SciShow Space, and thanks to all of our subbable subscribers who make this channel possible.
Okay, so how did the asteroid belt likely form? A small planet collided with a comet, other protoplanet, leaving trillions of space rocks ranging in the size from dust asteroids 1/4 the size of the moon. Particles of various sizes left over from when the solar system formed that could not form into a planet. Laser cannons from the Pioneer's 10 spacecraft blasted apart a small protoplanet to avoid a collision on its way to the outer planet in 1972. And of course, we know that the asteroid belt is made up of chunks of rock ranging from a few feet to several hundred miles wide. Most of the asteroids are small, but at least 40,000 of them are a half mile or more across. The asteroid belt formed from material left over from the formation of the solar system. Okay, moving along. The asteroid belt is estimated to contain between 1.1 and 1 million asteroids larger than 1 kilometer or 0.6 miles in diameter, and millions of smaller ones down to 1 meter or only 3 feet in diameter. The rest of the objects in the belt are smaller rocks and dust particles. Ceres and the 3 largest asteroids account for most of the mass of the asteroid belt. And there you can see there's Ceres, Vesta, Pallas, and Hygeia, and it gives you their distance in diameter. Okay, Ceres is now classified as a dwarf planet, even though it is in the asteroid belt. And remember in that video we just watched, it talked about how there is water ice is made up of the outer core of Ceres, the outer layer, Near-Earth asteroids are those that have orbits that pass close to the Earth. There are at least 10,000 known near-Earth asteroids, with almost 1,000 over 1 kilometer in diameter. Some of these actually cross Earth's orbital path and are considered to be potentially hazardous to Earth. Asteroids have hit the Earth in the past. That is kind of scary to think about. So that's it, guys. That's what we did today. So going back and talking about the project itself, you need to make sure you're keeping up with these videos. They're going to remain posted on our Google Classroom. Make sure you are working on that galaxy, which is the background to your solar system project. We're writing 5 facts about each planet or part of the solar system. Color your planets the correct color. We will tomorrow make sure everyone is caught up on graphing the distance that each planet is from the sun on this scale at the bottom of the project. And then tomorrow we will do 2 more planets, okay? So just be working really hard on that project, make it look as best you can, make sure you've got it put together, and then I'll set a date where those can be brought in and you can get your project grade. Remember, that's 200 points for a project, okay? A very simple project. Oops, I did not mean to do that. A very simple project that I think is going to turn out to be really, really great. So I appreciate you guys coming in. I hope you have a great day. See ya.